Alrighty, welcome back. In this video, we're going to look at a couple independent samples t-tests, which are used to check for mean differences between two independent groups, two independent samples. So question number one, a researcher wants to know if amount of time spent on the internet per day is significantly different for men and women. The researcher collects a sample of 10 men and calculates the mean as 90 minutes with sum of squares equal to 120, and a sample of 10 women and calculates their mean as 75 minutes with sum of squares equal to 150. Do the data indicate a significant difference in amount of time spent on the internet per day between men and women? Use a two-tailed test with alpha of 0.05 and then calculate effect size and a confidence interval. All right, so essentially, first and foremost, we're doing a two-tailed test, which means we're simply checking to see if a difference exists. We're not checking to see if men are higher than women or if women are higher than men. We're just doing a more generalized test. And so let's start with our hypotheses. As always, you have the null and alternative hypotheses. And let's get into the right... Let's get into the right module here. Here you go. Okay, so the hypotheses look like this. So the null hypothesis, as always, is the one that says no effect, no difference, no change. So in this context, what we're saying is that the average for group 1, which we're going to call men, is equal to the average for group 2. There's no difference between these groups, whereas the alternative, H1, says there is a difference. Mu1 is not equal to mu2. Okay, now step number 2 is to establish your decision-making criteria, which means you have to have your critical values of t. And for this type of question, we have two samples. And so the first thing I want to do is get my degrees of freedom for each group. So for the first group, the men, degrees of freedom is 10 minus 1, which is 9, and then therefore the degrees of freedom for the second group, which is women, is also 10 minus 1. So there's 10 people in each group. 10 minus 1 gives me 9 degrees of freedom in both groups, and therefore degrees of freedom in the entire study, I call it total, is 18. So you can think about as using this formula right here. Take degrees of freedom for each group and add them together, or the number of people in group 1 plus the number of people in group 2, 10 plus 10 minus 2. Either way, you get 18. And we're doing a two-tailed test with alpha of 0.05. And so let's go ahead and find our critical value. So here's 18 degrees of freedom. And we're doing a, was it 0.05, I believe? Yes, alpha of 0.05, which is two tails. And that's this column right here. So scroll down to where you see 18 match this alpha level. And so it looks like the critical value of t is 2.101. All right, so that is 2.101 over here, but it's negative 2.101 down here since we're doing a two-tailed test. Okay, so essentially the difference between our two samples has to be 2.101 times 2.101 standard deviations different than what would be expected by chance alone if there were no difference between the groups. All right, so just like in all of the hypothesis test questions, we calculate our test statistic. Here it is, the t value we care about, and we compare it to our critical value of t from the table. The difference in this type of question for chapter 10 is that we have two samples, men and women in this case. And so we have an extra step, which is this formula right here, pooled variance. Essentially, pooled variance is it's like average variance between your two groups. And so the men, they have variance. They don't all have the same score. The women, they all have variance as well. Pooled variance will tell us average variance between the two groups. So let's go ahead and calculate that. The SS for men was 120 SS for women was 150. And then divide by your degrees of freedom for each group, 9 plus 9 or 18. Looks like pooled variance is 15. All right, so we use that value to calculate our estimated standard error. And here we go. So I'm seeing 1.73. The interpretation of that would be as follows. If there really is no difference between men and women, but you randomly sample 10 men and 10 women and measure their internet usage, you would expect to see a difference on average of 1.73 due to random chance alone. So now we actually calculate the test statistic to see if the difference we actually found between the two means is statistically significant. All right, so M1 for men was 90. Compare that to M2 for women, 75. And then divide by the estimated standard error of 1.73. So it looks like it's going to be a pretty large difference, 8.67. The difference in internet usage between men and women, these two samples, was 8.67 times larger than what would be expected by chance alone. And the cutoff that we needed was only 2.01. So the conclusion here is reject age 0. That means there was a statistically significant difference in internet usage. So then how large is that difference? We're going to calculate effect size. So Cohen's D, the estimated Cohen's D, is the formula right here. And your cutoffs, small, medium, and large. Let's go ahead and calculate that. Excuse me. All right, so then square root of pooled variance. Looks like a value of 3.88. Very large. So there's a very large difference in internet usage according to this data between men and women. R squared. Also another measure of effect size. 8.67 squared. Divided by 8.67 squared plus degrees of freedom, which was 18. I'm saying 0.81. And so the cutoff for a large value is 0.25. So this is very large. There's a very large difference in internet usage between men and women according to R squared. All right, the last thing this question calls for is a 95% confidence interval. Here's a formula down here. We're going to use this to estimate the true population mean difference in internet usage between men and women. Make sure you use your T critical value from the table, which was 2.101, and multiply that by your estimated standard error of 1.73. So 15 plus and minus 3.63. So on the lower end of the interval, we get 11.37. And on the upper end, we get 18.63. So we are 95% confident that the difference in internet usage between the population of men and women is between 11.37 and 18.63 minutes per day. All right, so that concludes this problem. We did the basic hypothesis test, as well as measures of effect size, as well as a confidence interval. Let's look at one more problem with a slight modification. And here we go. Numerous studies have found that males report higher self-esteem than females, especially for adolescents. And so that was determined by Kling and colleagues in 1999. Typical results show a mean self-esteem score of 39 with sum of squares of 60.2 for a sample of 10 male adolescents and a mean of 35.4 with sum of squares of 69.4 for a sample of 10 female adolescents. Do the results indicate that self-esteem is significantly higher for males? Use a one-tailed test with alpha of 0.01. All right, so here we're doing a one-tailed test because we have a specific prediction about the direction of the difference between males and females, the difference between our two independent samples. So in this case, we are checking to see if males have higher self-esteem than females. Not just if there's a difference, but specifically if one group is higher than the other. And it's interesting to note that a study has already confirmed this in 1999, or at least provided evidence that males report higher self-esteem than females. Just because we report something doesn't mean we actually have something. But anyway, the idea is that we're trying to replicate those findings. So we're going to do a one-tailed test, and let's start with our hypotheses, H0 and H1. For a one-tailed test, the alternative hypothesis is the one that includes the prediction about the direction of your effect. So we expect group 1, males, to have a higher self-esteem on average than group 2, which are females. And importantly, I just want to take a quick side note. This is males' report of their self-esteem compared to females' report of their self-esteem. And any psychologist will tell you that we don't always know ourselves as well as we might think. So I might claim to have a high self-esteem, and that's actually maybe a defense mechanism. Anyway, back to the problem. The null hypothesis states essentially that the prediction is wrong, so that males do not have a higher males do not report a higher self-esteem. Either it's less or equal to females. Okay. So let's find our critical value of t. We're doing a one-tailed test with alpha of 0.01. And so first we need our degrees of freedom. So degrees of freedom for group 1, the males, there are 10 males. So 10 minus 1 is 9. For females, there's also 10 females. So 10 minus 1 is 9. And just like in the last problem, degrees of freedom total is 18. All right, let's just kind of separate this here. So going to our t distribution, we're using a proportion of 0.01 in one tail, and the degrees of freedom are 18. So I find out where those match, and it looks like the value is 2.552. 2.552 is our critical region, or the cutoff for the critical region is a t-value of 2.552. So if our calculated value is 2.552 or higher, we can reject the null hypothesis. And so let's go ahead and do that. The next thing we want to do is calculate pooled variance, figure out how much variance is in these groups on average. And so the sum of squares for males was for males it was 60.2. Add that to the value for females, 69.2, divide by degrees of freedom for each group added together. All right, let's calculate that, see what we get. I'm seeing 7.19 after rounding. And then we can calculate our estimated standard error of the mean difference. How much, basically what this is how much difference we would expect due to chance alone when you randomly sample 10 men and 10 women, 10 males, 10 females. So let's calculate that. That should be a 10. Let's make that more clear. The stylus is not the easiest thing to work with, but I think it's helpful for an online class. All right, so without further ado, let's get into the calculations here. And I'm seeing 1.20 after rounding. It is, by the way, certainly always possible that I make mistakes in these videos. So if you find an error, please email me so that I can confirm that there's a mistake, and I'll email the class so that everyone's on the same page. I try not to make errors, but you know, I'm a human. Anyway, the last step here is calculated value of t. So I'm just going to separate this. T, our T test statistic, is as follows. So the males reported a value of 39. The females reported an average value of 35.4. Divide by your estimated standard error of 1.2. And I'm seeing a value of 3. All right, so the cutoff was 2.552. Our test statistic was 3. Therefore, our conclusion is reject H0. All right, so that just means that there is a statistically significant higher amount that males reported compared to females. Okay. So let's move forward and calculate effect size. So next, Cohen's D is as follows. 39 minus 35.4 divided by the square root of your pooled variance. And I'm getting 1.34. Very large. Let's calculate r squared. 3 squared, which is our t value squared, over 3 squared plus degrees of freedom. So 9 over 27 looks like. 0.33. And you could say very large for that as well. So up until this point, we have the following. There is a males reported a statistically significant higher amount of self-esteem compared to females, and that amount is very large according to Cohen's D and r squared. Okay, let's just do 2 more things. First, let's do the confidence interval, and then we will write the conclusion statement as you would find in a published report. So confidence interval is an estimate of the true population mean difference. And here we go. 39 minus 35.4. Having some issues here. Plus and minus our critical value of t, which was 2.552, multiplied by our estimated standard error of 1.2. And that gives us the following. So we have 39 minus 35.4, which is 3.6, plus and minus 3.06. So we get the following. 0.54 on the lower end and 6.66 on the upper end. So we are 99% confident based on probability, of course, that the true mean difference in self-esteem reports between males and females is 0.54 and 6.66. All right, there you have it. So last but not least, let's type up a conclusion statement the way it might appear in a published report. So here we go. Say something like males reported significantly higher self-esteem than females. One of the things I actually think is nice to do is next to each group, put the mean and a measure of variability. So for males, the mean was 35.4, and the measure of variability we have is, for males it was 39, and the measure of variability we have is sum of squares, which was 60.2. And then, so males reported significantly higher self-esteem than females. And for females, the mean was 35.4. SS equals 69.4. And then I'm going to put comma. And then I'm going to indicate what test I did to make that conclusion. So I did a t-test. In parentheses, I have my degrees of freedom for the entire study, which was 18. The t-value was equal to 3. P is less than 0.01 since I used an alpha of 0.01 and rejected H0. And then my estimated value of D was 1.34, which was very large. My R squared value was 0.33, which is also very large. And then finally, my 99% confidence interval ranged from 0.54 to 6.66, period. And let's make that a little more legible. All right, so there you have it. Males reported significantly higher self-esteem than females, according to this data. And there's all my statistics that led me to that conclusion. Okay, so there you have 2 example problems related to an independent samples t-test.